All right. I don't know why that was muted.
All right, you're good.
All right.
Roll.
Cool. So state history in Redux with undo redo functionality. So there are a few libraries out there that do this. If you Google, Redux history, you'll come up with a bunch of browser history, Redux related stuff. So if you Google Redux undo redo, you'll find a few libraries. But first, you'll need to know about reducer enhancers for any of those libraries. And a reducer enhancer basically is a function that takes your reducer, returns another reducer that then calls your original reducer. So yeah, you see in this first enhancer here, it just has a next, which gets the state of the original reducer, and then it does something else to the reduced state. Second reducer is like a skip action reducer. You pass it a function, should skip, calls that function with the current state in action, and if it returns true, it just skips reducing it. That's all reducers are. And they're pretty simple, but they can be pretty powerful. Redux actually has like an implementing undo history article. It's pretty long, so I'm not going to go over all of it. But the gist is they go over, creating this undoable state here, creating a reducer for it, and then they turn that reducer into a reducer enhancer. And this is the entire Redux undo, basically, that they create in this article. And by default, it just saves your history if it's changed, and the undo and redo actions just rearrange your history. It's pretty simple. Now, the these other undo redo enhancers don't necessarily keep the states. Redux undo does keep previous and future states. And I say keeps here because it doesn't actually copy it. It just saves a reference to your state. And that's important later when it comes to memory usage. I'll get to that. Redux undo requires a state shape change. So if we go back to the docs for this, you can see here, wrapping a reducer with undoable makes the state look like this. What this means is that anywhere you access your state, you now have to do state.present. So if you're adding this into an app later, it's going to require a small refactor, but still it's a refactor nonetheless, changing all of these things. These other undo redo enhancers actually work with actions, and you must define a reverting action to undo actions. And they don't store state, so you can't retrieve those previous and future states unless you have some other store that only gets the old history from those actions they save. Redux undo redo actually has a whole separate like smart action thing it uses, so I'm not going to glance over that. But Redux undoable, you can see here, is it does also change your state tree. Whereas to-dos used to be an array, now it becomes this. Oh. They keep your actions in the past and your current state in the present, and they just juggle stuff around the same way Redux undo does, except they work with actions rather than the state. So my problem was I wanted to be able to undo and redo actions, which I can do with any of those enhancers. I want to show the history in the UI. That actually eliminated all but redux undo because I want access to that history. Right. These last two I have a little asterisk by because these are specific for my needs. I want to store the history for future reference. So in my example, after a game is over, I want to be able to look back and see the most properties that were bought in a game of Monopoly.
But you just want to be able to see like the actual timeline, not anything that was redone.
Yeah.
Redone, right?
Yeah, exactly. I just want to see the timeline from start to finish of how the game went or how a balance goes. Like this could be used in like a banking app too that can show you your history of what your balance is. And then I also need to keep my memory usage down because in my specific example, I'm using Redux on a server where there could potentially be dozens of these games playing. So if these game state gets very large, it's going to be dozens of these very large states hanging around in my memory. So those two were pretty important. And I wasn't sure exactly how Redux undo fared with those last two. Now, obviously storing the state, that's going to be a big state if it's just keeping the old state for every single action. So what about diffs? This is when I came up with redux-deep-diff, Instead of keeping previous and future states, it just keeps the diffs for these states, and it provides a way to retrieve previous and future states by simply applying or reverting these diffs. And it doesn't require state shape change because it just adds a little leaf in there. You can see what it looks like. It uses the deep diff library, which is pretty popular. The deep diff library just provides one function to get the difference between two objects. And this is what the diffs look like for, the difference between two objects. So that's a single change set from a diff is up here. So if I had an action that, changed the text within the object, it would create a diff that looked like that. This diff enhancer down there is just a really, really simple example of getting a diff and adding it to your state using an enhancer. Redux-deep-diff obviously has some more functionality than this with undo, redo, jumping to different pieces of the state, and deducing pieces of the state from your diffs. But this is an extremely simple example of that.
So the diff that's up there, that is, if any part of the object changed, it will return it? Or is it, did kind change? Do I know that kind changed? Or does it just always return me the value of kind?
So what this diff object is actually pretty specific. Kind is the type of change that happened. This is all in the deep diff docs, where E is edit, A is like an array change, D is a delete change.
Got it.
The path is the path within your state where that change took place. So if it's nested, this would be an array of strings for each key in your state. The left-hand side and the right-hand side are the previous value and the next value.
This is not the shape of the old object. This is an actual diff object.
Yes.
Got it.
This is a diff object coming right from redux-deep-diff here. So yeah. When you pull a difference, these are the different types. You got edit, array. I can blow that up a little. Yeah, this is basically a difference object according to this library. The way redux-deep-diff is built is I can drop in any other library here and it'll just store those same diffs as long as the diffing library provides an apply and revert.
Right.
Like this has apply diff, apply change, revert change, etc. That's how redux-deep-diff actually does undos and redos, is it just applies and reverts changes. So how does it compare to redux-undo? Actually, I'm going to go and look into the actual state here. Oops. So this is the actual code for redux-deep-diff. So it just has an undo type and a redo type. It just reverts changes, applies changes. This just manipulates the next history object here. And up here you see the left-hand side and the right-hand side is basically what I had in that simple function, which was the state before and the state after. And then by default, it just accumulates the diffs. And this accumulator is specific for some extra functionality I have, so I won't get into that. But it just stores diffs and it reverts and applies them. And that's the entire reducer. Up there are just some helpers. So how does it compare with redux-undo? So I ran these comparisons in the actual app I'd be consuming this in, which is my Monopoly app. So this is all going to occur server side. So when I implemented redux-undo, the state shape is altered. So I had to go through to all of my files where I was referencing state and add state.present. And if I wanted a history, I had to map over state.past. With redux-deep-diff, it only adds the diff leap. I can actually go to the README here. And this is the only thing that redux-deep-diff adds to your state. It's previous diffs and next diffs. Everything else you just access from your state. The undo redo action is straightforward. And then for actually getting the state using redux-deep-diff, you have to deduce it because it has to do those calculations for applying and reverting changes. So we have this concept of deducers where you provide a selector and it just simply maps over the history of those states, applying and reverting changes as necessary. And deducers also are memwized. So if, here we go, right here, some examples. So yeah, when you first get the history using this deducer, count selector is called twice. If you do a couple things, count selector is only called a couple more times. This should actually be 3. Yeah, and these things will be equal here. because they are the exact same object we returned from the old selectors. If we just get the history again, count selector isn't called at all because there were no changes, so it doesn't need to select any other state. And yeah, that's just how reducer or the deducers work. In redux-undo, you could just reach into the past states, but then you still have to map over them with a selector. And then if you want to include the present state, that's a whole other property that's not included in that map you're doing. So yeah, definitely a code difference. Storage. So this is interesting. I have a little bot that I wrote for Monopoly, and it's just a simple 400-line bot, just chock full of if statements. And it saves it to a local Mongo database because that's what I'm currently doing in the server for Monopoly. And basically how it calculates the size is before we push it to the collection, we get the size. After we put it to the collection, we get the new size. Very simple stuff. So we can run bot in yarn. Run the bot, and it goes over a game. There's all the turns here. It's pretty quick, but yeah, it basically pretends it's a game of Monopoly. And at the end here, I print out some useful stuff. This took 62 milliseconds to get through this entire game. Now, the average entry in the database is 7.3 kilobytes, but the total size of this game was 1.4 megabytes. Now, when I actually tried to save this game without splitting it up into different entries, Mongo gave me an error that I was over the 16 megabyte limit. So that's a pretty big game. I'm not sure where this 1.4 megabytes is coming from if Mongo was telling me it was over 16, but that's what happened. I have another branch here for deep-diff. And right now there's a bug with deep-diff where I have to link it. But basically, we can run the same bot here. Goes over the game. So it took a little bit longer than before, but it's much smaller. It's not a megabyte. It's 200 kilobytes. The average size is 200 kilobytes. No, this average comes from the stats on MongoDB itself. I've ran this dozens of times, so the database is just filled with different games, and that's the average size. Excuse me. So yeah, that's how I got the size difference here. Is I'm just using it where I would actually use it to calculate these comparisons. With memory consumption, I can just make a little change in here. So let's go over to the redux-undo branch. And so if I just comment out closing the database, this will cause this whole process to hang, and then we can inspect it. So node inspect bin bot. I'll play through the game, and then it just chills there. So, whoops, probably open a new window. All right, so if we go to Chrome, inspect, give it a second. Usually takes Chrome a minute to pick up any node processes. There it is. Inspect that, hop over to memory and take a snapshot. Now, something specific I did in here was I have this global games, and I cache all the games so we can inspect the actual memory it's taking up. So if we look into this global object, we see games for redux-undo is about 700 kilobytes, give or take. This is pretty, actually we don't even pop up there. So if we go into here and see the present history is actually only about 4 kilobytes. So the game itself is 4 kilobytes, but because of all the history objects, it's inflated this game up to 700 kilobytes, which is pretty big, but not terrible considering it's saving the entire history. And the reason it's not bigger is actually because it's not copying the state. It's just keeping references to the state you've already made. So all those pointers are pointing to the same objects. So if during a state change, you don't update an object, you don't return a new object, even though it keeps that old history, that object is still referencing an object that was pre-existing. So it doesn't create any new pointer, or it creates new pointers, but no new objects and whatnot. That's why that memory is kind of small. in comparison to deep diff, oh, kill those changes and make those changes again. So kill that. Right, so one thing of note is that this is a little bit slower than redux-undo. It's because it's having to do that deep diff algorithm like each time. So if we look at the comparisons here, the redux-undo is actually pretty fast compared to redux-deep-diff. But considering this is for a game that's taken 50 turns, and in those 50 turns, where is this at? In those 50 turns, it has created, let's see, will this pop up?
But this is only taking that much time to do like the report afterward, you know, during actual gameplay.
Yeah, during the gameplay, it's going to be, yeah, fine. Yeah, this is just for, like, I take the measurement before the game starts, and then I take the next measurement when the game's over. So I don't know why this isn't popping up with a number here, like it does when I'm not screen sharing. But there's like, but there's like 250 pieces of state in this passed array.
Yeah.
Just because each turn can result in multiple pieces of state. You see player 1 mortgages property, player 2 bankrupts player 1, player 2 receives more money from pass and go, and improves their own property. Like each one of these is a whole nother state that's being kept by redux-undo. So redux-deep-diff, since it doesn't keep the whole state, it will just keep the one diff object that changed. So if you change a single property, it's only going to create that very small diff object as opposed to copying over the whole state. When we go to store it, it is much smaller. So the memory consumption is about the same because of those references, and because deep diff also makes those similar references. The storage is actually much smaller than redux-undo, because once this is stringified and stored in, I'm using Mongo, so it's stored as bson, like that all gets compressed in its own way, and it's much smaller to store diffs than it is to store 250 different states. And yeah, with Mongo, I had to split those states up because of that limit.
This reminds me of we were talking about variable fonts the other day. Like, same idea. Like you're just storing diffs.
Yeah.
For like each of the points of the letter forms instead of like the entire state every time.
Mm-hmm. So that was really it, but that I had for redux-undo versus deep diff. The rest of this I could talk about, like the memoized deducers that calculate state history, the ability to flatten diffs for a specific portion of the state. For example, if one of my properties was a notice that had a bunch of meta information associated with it, the diffs would end up having like 5 or 6 different diff objects for just that one notice portion of the state every single time an action happened. So instead, I have this ability to flatten diffs, so it'll just store a diff for that entire notice object. And again, those are pointers instead of new objects. So it's good for memory, and it's not in 5 different diffs, you know. We can also ignore pieces of the state completely. This is something kind of over redux-undo as well. With redux-undo, if you want to ignore different pieces of your state, you just have to get more granular with where you apply your reducer enhancer. So if you have a user object and you only want to keep track of their balance, you have to have a balance reducer, and you wrap your enhancer around that balance reducer. Otherwise, you're always going to store the full state every time. With deep diffs, deep diff, the library, actually has a function where if you enter part of the state you don't want to traverse, you can just back out completely and it'll stop looking at that part of the state. So that's also included in redux-deep-diff, so you can ignore pieces of state that you don't want to track while still having that single diff leaf on the outside of your state. And then customizable action types. I put an asterisk here because redux-undo also has this, but you could have multiple instances of this enhancer throughout the app and just have them react to different undo and redo actions. And yeah, so that's basically it. If you want to know more about any of these, you know, check out the readmes. Deep-diff has a decent readme, I hope. You know, go tear it apart. Although right now you won't be able to npm install it until I fix an issue. Yeah, I already got an issue open for it. So yeah, I will fix that later in the afternoon, and then everybody can play with it on the weekend. Any questions? I mean, we can't hear anybody.
We'll give Slack a minute. See if anybody types in. I want to see one of the deducers.
Yeah, so we can look at the. So this is a deducer right there. Like you have a selector that selects part of the state, and you create a deducer with the selector, and the deducer will map over the.
Map over the diffs.
Yeah, map over the diffs. I can show you the code for that whole. This is the create deducer function here. Basically just throws a warning about a couple options that it has. You might want to reduce only portions of your state or only unique pieces of history that have changed. Or you want to reduce future state in which you pass next true. You want to impose a limit. You have a limit option here. Or when you set up your reducer enhancer, you can also save it under a different key. So the deducer also has the function to look at a different diff key. But the deducer itself does a bit of caching, so it's not as simple as the reducer is. But yeah, the deducer itself here just.
I mean, I guess you can get away without that, yeah.
Yeah.
But it's there, so yay speed.
Yeah. Yeah, the main reason I have the cache stuff is so you could have more complex selectors that might map over a different piece of the state using another piece of the state instead of just selecting one portion of the state. My idea from that came from reselect, which is a pretty awesome library. So yeah, reselect also caches selectors, but you see here, like, if it does a reduce, you can compound selectors together and it'll cache it. And it does some pretty cool stuff. And I built redux-deep-diff with like this reselect in mind, so you can actually use these selectors with your deducers. Yeah.
I haven't think of any other questions. So.
All right. Cool. All right. Thank you, everybody, for watching.